Students, after completing the first loudspeaker, which is direct radiator loudspeaker, we'll begin with problems on direct radiator loudspeaker. Before that, I'll just revise the formulas what we discussed yesterday. So the formula what we got yesterday for the power was acoustic power, given W is equal to I square phi square RR by Zn square. Along with that, we have got a formula for efficiency also, which was phi square RR divided by phi square RR plus RM plus RE Zm square, correct? And this Zm square formula is nothing but RR plus RM bracket square plus XR plus omega m minus S by omega bracket square. Fine. Now one more formula we just discussed, which is condition for frequency response of mechanical resonance. Mechanical resonance, correct? Over here, the condition given over here is XR plus omega m, that is this term in the bracket, minus S by omega has to be equal to 0, and this frequency will be called as F0. Right? Okay, along with that, I think we have got all the formulas. So if at all in such formulas, if I is asked, you have to convert the formula accordingly. Should not forget that the value of phi, which is nothing but B into L, correct? So all this will be required when we solve the problems. So we'll begin with the first problem. So the first problem over here is a direct radiator dynamic loudspeaker has radiation resistance of 2.1 kg per second, correct? What they said, radiation resistance, so it is given RR. Its voice coil is 7.4 meter in length, so the length is 7.4 meters, and suspended in a magnetic field of, so B is 1.1 Webers per meter square. After these three things are given, determine the acoustic power output for a current of, so I need W. I have been given current of 1.9 amperes and the mechanical impedance is given here, so Zm is 13.2 kg per second, correct? So the formula what we discussed yesterday, that will be required over here. So formula is W is equal to phi square RR I square divided by Zm square. Zm is your mechanical impedance. So in this case, what all is given? Zm is given, yes. Is I given? Yes. Is phi given? Yes. B and L. RR given? Yes. So just substitute and get the value. So before that, I'll just find out phi. So phi is equal to B into L. How much is B? 1.1 Webers per meter square into 7.4 meters. 1 meter gets cancelled. So if you multiply that, you get the value of Weber per meter, and it comes out to be around 8.14. You can verify that. Substitute the values over here. So I get W is equal to 8.14 bracket square into RR. RR is radiation resistance, is given, the value is, unit is kg per second. So 2.1 kg per second into I. How much is I? 1.9 bracket square divided by Zm square. Zm also is kg per second, correct? So all values are in its proper place. So just simplify that and the answer you should get around 2.8828 watts. Verify that. That's what is the first question. Correct. Now we'll move to the question number 2. Question number 2 will try and take a little same one but a little different approach. So here we have been given a 3 watt. So here wattage is given basically. A 3 watt direct radiator loudspeaker has a mechanical impedance of, which means Zm, 13.2 kg per second and a radiation resistance of, so RR is how much? 2.2 kg per second. The voice coil is, so L, the voice coil is 7.3 meter long. So imagine a diagram which I drew yesterday. The voice coil was wound, okay, in the middle part near the air gap and the middle part of that magnet. So 7.3 meter long wire has been wound over there and suspended in the magnetic field of, so B is 1.2 Webers per meter square. Determine the current flowing through it. Correct. So we'll have to change the formula accordingly. So if the formula is W is equal to phi square RR I square by Zm square, as I need I square, what will I say? I'll say I square is equal to W into Zm square divided by phi square RR. Okay, as I need current, so I can very well write I is equal to Zm by phi under root W by RR. So this is my final formula to get the current. So over here Zm is given, yes, I just need phi. So how much is phi basically? Transformation factor. Phi is equal to 1.2 Webers per meter square into 7.3 meters. So Webers per meter is the answer for phi. Correct. So over here I need to get the value of phi, which comes out to be around 8.76 Webers per meter. Fine. Okay, afterwards what will I do? I'll substitute the values over here. So I is Zm, which is 13.2 divided by 8.76 under root W is 3 divided by RR is 2.2. Correct. So if you simplify this, correct, 13.2 by 8.76, okay, you should get the answer around nearby to around 1.75 or 76 ampere. So this is the way we can simply get the answer. Correct. Now we'll move towards little difficult problem with this condition. Correct. So over here, next question is question number 3. The frequency of mechanical resonance for a speaker is 57 Hertz. It's given to us. So my F0 is 57 Hertz. The stiffness of the cone system, till now I have not spoken, but as we have already used this word stiffness in microphone, so I assume that you are aware of it. Correct? So stiffness over here is S, where we have used S in the formula in the condition. So S is how much? 2 into 10 to the power 3 Newton per meter. Determine the radiation resistance, radiation reactance. So XR, radiation resistance should have been RR. Radiation reactance if the total mass of the diaphragm and the voice coil is 0.01 kg. So M is 0.01 kg. Correct? So with this, what is the condition? The condition is XR plus M omega minus S by omega has to be 0. Okay. How much is omega basically? Omega is angular frequency. So 2 pi F0. Is F0 given to you? Yes. So 2 into 3.14 into frequency is given out to be 57 Hertz. Correct? So if you simplify that, you will get the value of omega. Correct? So if you take it 57, or we'll take it 60 first. 57 we'll do it later. So if you use the value 60 over here, correct? We are going to get the answer to be around 376.8. Fine. Okay, after getting this, what is my next job now? My next job is to substitute and get the XR. So now do I have everything now? Yes, I know S, I know omega, I know M. So I can very well get the XR. So what is the XR now? XR is minus M omega, correct? Minus M omega plus S by omega. So how much is M? M is 0.01 kg. So 0.01 kg, don't forget the minus sign, into omega. How much is the omega? I got the answer 376.8. Fine. Plus, what is S? 2 into 10 to the power 3. Fine. Divided by 376.8. Fine. So multiply this, you will get some value, plus this by this. Okay. So this is the way you will get the value of XR, and the unit will be kg per second. Do this. Find out the value by which you will be able to understand how we are supposed to get such answer. So 2 pi f. Okay, not very complicated thing. So this is the way we'll try and get the answer. We'll take one more in similar lines. Okay, so next question will be same logic. So here I'll try and use the few things. As I mentioned, we'll take the frequency of the mechanical, question number 4 I should say. Question number 4, the frequency of a mechanical resonance for a cone speaker is 57 Hertz. No problem. So again the same value, 57 Hertz. Stiffness same, 2 into 10 to the power 3 Newton per meter. Determine the radiation reactance, again XR. Okay, and the voice call is 0.01. So everything same. I think I just changed the frequency. Fine, not an issue. So obviously try and get omega. So omega is 2 pi f omega, omega 0. So we'll say omega only. So 2 pi f 0. So 2 into 3.14 into 57 will get around 357.96 radiation per second. Radians per second. Okay. Afterwards, what I'll have to do? XR. What is the condition? I wrote it over here. XR plus omega m minus S by omega has to be 0. This is my condition. Okay, so therefore XR should be minus m omega plus S by omega. How much is m? 0.01. How much is omega? 357.96. How much is S? 2 into 10 to the power 3. How much is omega? 357.96. Correct? So if you simplify this into this, correct, this comes out to be around verify, not an issue. I will not tell you the simplifier, directly give the answer. It comes out to be around 2.0074 kg per second. So this much is the range of your value of XR. That's what I can say over here. Next one. Next problem now. So next problem is question number 5. Yeah. A direct radiator loudspeaker has total mass of 0.01 kg and operates in magnetic field of 1 Webers per meter square. The radius of the speaker is 0.1 meter. The mechanical resistance is 1 kg per second. Mechanical resistance is 1 kg per second. The radiation resistance and radiation reactance each are 2 kg per second. So it means RR is equal to XR is equal to 2 kg per second. The stiffness of the cone, which is smallest, is 2000 Newton per meter. the voice coil is length is 7.5 meter long, has a resistance of 10 ohms Re. Fine. And the inductance is 0.005 Henry. Fine. Calculate now the following quantities at frequency 200 Hertz. So frequency is given to be 200 Hertz. What do you have to find out? We have to find out three things. First is frequency of mechanical resonance, so F0. Second thing we have to find is efficiency, electroacoustic efficiency. And third thing is acoustic power, which is W, for input current of 2 ampere. So current is also given 2 ampere. So there are many things, it's a little bigger problem. So we'll go step by step. So first we'll try and find out F0. So in finding F0, what is the condition first? What we mentioned over here. Condition for resonance is XR plus omega m minus S by omega is equal to 0. So this we'll have to solve. So XR plus omega m minus S by omega has to be 0. Okay. Do I know XR? Yes, it's given. So 2 gauge. How much is omega is not given. Okay, how I need to find out first actually F0. So how much is m? M is 0.01. So I'll write 0.01 omega minus S. How much is S here? It's 2000 divided by omega is equal to 0. Okay. In this case, we can't do omega is 2 pi f because this because we can't directly use 200 Hertz and get the frequency. So you need to use this condition to get the answer. Correct? So if at all I simplify this equation, what will I get? This is omega over here. So I multiply here and over here. So what is the equation then? 0.01 omega square. Fine. Plus 2 omega minus 2000 is equal to 0. So this is as good as ax square plus bx plus c is equal to 0. How much is a? 0.01. How much is b? B is 2. How much is c? C is minus 2000. Fine. Okay. Now use this in an equation where we will be able to get the value of omega very easily. So the quadratic equation, I had to get the solution. So what is we say solution over here? In this case we say x. So what is the formula we use? X is equal to minus b plus or minus under root b square minus 4ac divided by 2a. In my case, I will get the value of omega. Correct? So omega will be minus b. How much is b? B is 2. Plus or minus. How much is b square now? This is 2 square, so 4. Minus 4. How much is a? 0.01. How much is c? Minus 2000. So I'll make this plus and write this 2000. Fine. Divided by 2a. So 2 into 0.01. Clear? Simplify this further. So this will be minus 2 plus or minus. This is 4. This is 4 into 0.01 will be 0.04 into 2000 divided by 0.02. So if you simplify this, we will be able to get two answers because one with positive, one with negative. Correct? So I'll say the first answer will be minus 2 plus 9.165, which is the under root value of this, divided by 0.02, and second choice will be minus 2 minus 9.165 divided by 0.02. Correct? So here the answer I will get will be 358.25 radians per second or minus 558.25 radians per second. So omega can't be ever negative. So we will cancel this. So we can't take negative value and we say therefore omega has to be 358.25. So in such problem you have to show this, correct, that you get two answers, but this is not possible. You can't have angular frequency to be negative, so the positive value. Fine. So with this, after you get that, then we'll have to use omega is equal to 2 pi f0. Fine. Then get the resonance frequency. I need resonance frequency, not normal frequency. This is given to you. So therefore f0 is equal to omega upon 2 pi. So 358.25 divided by 2 into 3.1. So this is the way we have got the answer to be around 57.046 hertz. This is my first answer, which is resonance frequency. Fine. Okay, afterwards, second thing what they asked is efficiency. What is the formula for efficiency? This is the formula. Phi square RR upon phi square RR plus RM plus RE ZM square. Correct. So now in this case, we need to find many things. Okay. So first we'll check, is ZM given to you? No, it's not given to you. So we'll have to find out that also. So in finding this, so to get the efficiency, the second one, what is the formula I said? Efficiency is equal to phi square RR divided by phi square RR plus RM plus RE ZM square. So first job is to get the value of, okay, is phi given to you? No, we have to get phi also. So many things we'll have to get. So we'll first get ZM square. Before that we need even omega. So omega is basically 2 pi f. How much is f given? Given to you is 200. So we'll say 2 into 3.14 into 200 hertz. Correct. If we simplify this, we get 1256 radians per second. Now I'll use the formula for this Zm square. So what is Zm square formula? Zm square is equal to under root RR plus RM bracket square plus XR plus omega m minus S by omega bracket square. This is the value. So how much is RR given to you? Values are given in front of you. Okay. RR is 2. So put the value 2. How much is RM? RM is 1 bracket square. Now how much is XR? XR also is 2. How much is omega? Just now I found out. 1256. How much is M? M is 0.01. Fine. Minus S. How much is S? 2000. How much is omega? Is 1256. Square it. So simplify this. So this is 3 square is 9. This is 2 plus 12.56 minus 1.59 square. 2000 by this much. 1256 into 0.01. Okay. So if you simplify this, we get answer to be 177.22 kg per second. We need Zm square only, so don't have to bother too much. Now next is phi. How much is phi? Phi is equal to transformation factor B into L. How much is B given to you? It's 1 Weber per meter square. And how much is length given to you? 7.5. So this will be 7.5 Webers per meter. I think we have got everything now. So we'll put the value accordingly in formula. So efficiency is equal to phi square, which is 7.5 bracket square into RR. How much is RR? RR is 2 divided by phi square. How much is phi square again? 7.5 square into RR plus RM. Don't cancel this. Into RR plus RM. How much is RR plus RM? Is 3. Plus RE. How much is RE given to you? 10 ohms. Correct. So plus 10 ohm into Zm square. How much is Zm square? 177.22. Correct. So if you simplify this, we will get the efficiency to be around 0.05796. If you multiply, divide by 100, okay, we'll get in percentage. So that is around 5.7%. That much is the value over here. And the last part left is acoustical power. So that is W. So W is equal to, formula is phi square RR I square divided by Zn square. Now we know everything. Now we know phi is how much? 7.5 bracket square. How much is RR? RR is 2. How much is current given to you? For this case is 2 amperes. And how much is Zm? Is 177.22. Already square. Don't square it again. This is Zm square only. Okay? So if you simplify this, we will get the answer to be around 2.53 watts. So this is the way we can solve the bigger problems also in this fashion. Okay? Thank you very much.